essentially, we have, is the sky falling with Border Gateway Protocol? Do we have a big security problem with it? Now, hopefully for most of the people here, I hope, but that a lot of this is like no duh, all right? Best common practices with best Border Gateway Protocol configurations really help to add a lot of security robustness in the internet, okay? But post 9/11, with a lot of new people coming into security and infrastructure protection and what's going on with the critical infrastructures of the nation's network, and then there's a perception that the internet is now a critical infrastructure. They all started saying, oh, wow, okay, Border Gateway Protocol, DNS, and of course we add in this one caffeine. Those are the three core critical infrastructures of the internet, right? You got to keep all three. So the question is there a security problem with Border Gateway Protocol? And one of the things I ran into is me, I have an attack lab over Cisco. I do security all the time. I work with security teams and ISPs, and all of a sudden I get pulled in with the U.S. government, and they said, oh, there's a SBGP protocol, hence there must be a security problem, and BGP is totally insecure, right? So you get this mismatch, right? And I look at it and say, well, wait a minute, I'm not seeing, the internet falling down around us, right? So we work around October last year when we started to get a lot of new people coming in and saying there's a security problem, and they have this perception there's a security problem. Around February this year, the National Security Council, this is what Avi's going to talk about, pulled together a bunch of operators, and actually they were pretty clueful. I mean, Dick Clark's organization was pretty clueful in trying to find clueful people who actually was doing the job out there, and pull us together in a working group. Get into that working group, and immediately I find out that, again, I'm running this perception that there's a big problem. So we dive in. I got a couple of colleagues. I got a list of us in behind. A couple of people from Lucent, a couple of people from Juniper, a couple of people from BBN, who all kind of dived in and said, what is really the risk assessment? And on the site, we got a little white paper, and we got this presentation that works off the white paper to say, do we have to worry about something right now? All right. So off we go. Now, luckily, our luck still holds out, right? We got a nice, reasonably operationally stable internet out there, all right? We also have been lucky in that we've gained a lot of security resistance just because of all the operational lessons we've learned over the years. All the stuff we learned with CIDR and the things we had to do for CIDR added security resistance. All the stuff that happened with our route flap dampening experience added a lot of security resistance. All the stuff that we had to do with ingress and egress filtering added a lot of security resistance. So over time, in operational outage, and the thing we had to do for operational outages with the different filtering techniques that we did, added more security resistance to the BGP infrastructure out there, right? So the bottom line with all this, as long as you're following best common practice principles out there, you're in pretty good shape, right? So that's the bottom line. Now, trying to communicate that to all the new people coming into this, that's been our challenge, all right? The other thing is just inherently from the very beginning, the way Border Gateway Protocol was designed, very common sense principles, the guarded trust sort of paradigm that we use, because, you just don't trust the prefixes coming into you, you put a filter up, right? And a peering agreement is basically two providers who put up, practically two identical filters to enforce a peering agreement, and, Murphy's Law of Networking, if one filter goes down, the other filter takes over. Now that, as we have learned through operational incidents, say like 7007 incident, we had compartmentalization on the internet. There were some providers who were really affected by 7007. There are other providers who they had to page somebody to, one of our colleagues out here, he told me, oh yeah, somebody had to page me to tell me it was going on. I didn't know what was going on because he had very aggressive filters coming into his network. So, and we see that with unauthorized route injection, incidents out there where somebody, like for instance, in the last talk of somebody sends in advertising for a route. You don't see that everywhere. You only see it in some places. So we have compartmentalization. So this, designed into the protocol from the beginning, has really helped add resistance to it. So what I'm going to just go through here is I'm going to quickly walk through what we presented as the perceived risk. And one of the reasons why I can do this now is right from the beginning in my past work with the government, I knew that any material that we would submit into them, they would decide when they're going to take it out to the public. And so what we did with this is we decided, well, you kind of know, Philip and I, we got this ISP Essentials white paper materials we put out there. So we put this as a supplement and copyrighted it, and then gave the government permission to use it. So now I can present it here, and the rest of the stuff you have to wait until the fall. All right, and then lead into what's next, because we do have some what's next sort of activities going on, primarily in IETF, and we want to encourage participation in those what next sort of activities. Right from the beginning, I ran into this even inside Cisco. I had guys inside Cisco that says, oh, it's very easy to spoof BGP. Spoof BGP, send a reset in, drop the TCP session, the BGP session goes down. I go like, well, if it was that easy, we'd probably see a lot more of it out there. Why isn't it? So I go into my tech lab and start throwing up tasks, and I'm going like, this is kind of hard. Why is it hard? Walk into the developers. What's going on here? Why is it so hard? And it comes down to, and I was comparing notes with Paul Triana yesterday, right? So this is kind of like out there, BGP implementations that, you got to match the source address, match the source port, hit the match the destination port, right? Hit the TTL. If you're eBGP session, you got to hit that TTL. If you go in with a TTL of 16 to an eBGP session, it goes, well, I'm looking for a TTL of 1. I'll drop that, okay? And then hit the sequence number, right? To get in there, right? So that's just to get in. So it's not just spoofing a sequence number; it's spoofing multiple things to get into the BGP process. To get the TCP session started for the BGP process, right? So you need to get in wiretap. Right, is basically the risk assessment here, and since there's so much private peering out there, if somebody's wiretapped on a OC12, you've got other problems, right? I don't think they're going to sit there if somebody's wiretapped in OC12 and hit little BGP resets at you. They'll probably do other things, right? And then there's MD5, but we have our deployment issues that we're trying to figure out to work out with MD5. So you put MD5 on the BGP peer connection, and then there's another thing you have to deal with just to spoof. Now, spoofing is a prerequisite to do a hijack, right? Now, we got Sandy Murphy. Sandy Murphy did a good breakdown of what if you went in and hijacked a session and did a fake BGP update into the table. What can you do there? So her work, I got references at the end of the presentation. Look through that. It's good material there. But you got to spoof it before you can hijack. Right, so there's a little prerequisite thing going on there. So this risk didn't seem, a big out there. Route flapping. What if somebody, took over a router and started flapping lots of routes? Well, we got route flapping. We've been through that. We grew through that, and hopefully, is the best common practice thing. People are doing, right now it's 229, right? So luckily, we had the guys over on Right many years ago said, well, wait a minute, why are we listening to Cisco's default for dampening? That's dumb. Let's go through and do some real good studies and figure out what we really should do. And so we got this work that continues on. This is lessons learned. So as long as you're doing 229, you're doing pretty good. Deaggregation. Now, deaggregation comes out, and this is where this is actually a valid, these next few things are valid kind of threats that we do see incidents like this. The reason why we see it, because like Rob Thomas, some of you know Rob Thomas. He's got his templates and provide good materials. So Rob and I will get on the phone and we'll waddle in our paranoia as what could happen to the internet with people breaking into routers. And we got good intelligence that there's a lot of CPE routers out there that are broken into. The organization who owns the router, by contract, right, does not own the router. Some kid really owns that router, and the organization doesn't know about it, right? And thankfully, what a lot of those, cyberpunks are doing is they're using it for go into it and launch GRE tunnels to kind of obscure where they're coming in from the real attack. So they're using it as redirect points. But a lot of these are multi-homed. Right? They're multi-home routers taking full BGP routes, and they can say, what could happen if I deaggregate and send that in? Which is Op 7007 was an operational incident, but those sort of things could happen, right? And this is I call these things garbage in, garbage out incidents. And this is kind of like a problem because we don't have a wide range across the internet, people doing ingress filtering on their customers and egress filtering going out to their peers. Lots of people do ingress filtering from their peers. So ISP, ingress filtering is happening, right? But on their customers, just like we don't have BCP 38 going on in the packets, a lot of ISPs don't bother putting on BGP filters on their multi-homes, right? So that means somebody who takes over a little router down there, a little router in down there, somebody takes over and says, oh, let me deaggregate, all right, and let's see what happens. And then the egress filtering going out to the upstream peers, they just send the garbage out. So garbage comes into an ISP, garbage goes out to an ISP, and then you have a situation where you have, a bunch of networks under duress, right? And we have another 7007 incident. Now, luckily, how you can protect yourself against that is some sort of ingress filtering. Again, if something like this happened, we'd have compartmentalization. Some providers will be affected, other providers won't. So even though this is a valid threat, and we do see this happen every now and then, it's not going to take out the internet, right? So that's impact with this. So proper filtering takes care of this. Again, best common practices adds a lot of robust security to your network. And the key thing, if you really want to prevent it, is the filtering down on the customer side. When you got multi-home customers coming in, put those BGP filters on. Only allow specific prefixes that they are allocated to do. And yes, it gets painful sometimes when they multi-home with multiple providers. You got to punch holes in the blocks to allow your, other ISPs blocks to come through there. But how often does that change? It doesn't change all that often. Documented special use addresses, right? We've had lots of studies about, the RFC 1918 addresses going out there, right? And this periodically pops up. You put the route filters on there, you mitigate against this sort of threat out there, right? Common sense sort of stuff. And now IANA, I don't know if a lot of people saw this, but IANA is putting out a document, putting more detailed on the documented special use addresses. So this is the IANA draft that's up here. And if this is totally new to you, right, and maybe somebody watching this tape in the future in the archive, somebody starting up ISP, go to Rob Thomas's template, because Rob Thomas makes it easy. You go to his templates, and there's your starting point to get yourself going. So there's people out there who've made it easy to get started with these sort of filtering, all right? Unauthorized route injection. Well, we heard with the routes, right? We've seen incidences there. I've seen incidences where major content providers, somebody goes out there, takes over a router, injects a major content provider, right? And these sort of things, when they send an unauthorized route injection into a network, and it gets through the filters, they become a double DOS, right? Because one, the prefix you send in there, traffic moves from their site, so they're DOSed, but then traffic moves to somebody else, and then they're DOSed, because sometimes these are big content providers, and the traffic hits them, right, and everything in between. So it causes stress on the network of these sort of incidences. So again, route filtering, protects against this, right, for unauthorized route injection. I put the same slide up there to show that again. Bogon risk. Now, bogon filtering, people say, should I do bogon filter or not? Should I allow bogons go out? If somebody can break into a router and send out a bunch of bogons, right, and the bogons go out, what happens? Well, look at script kiddie tools out there. Script kiddie tools, to keep the source obscure, commonly use bogon addresses, right? And bogons are the addresses that we have not yet allocated out to the internet, right? And they use bogon addresses as a source, right? If they haven't been allocated internet, they're not in the route table, you can't get back to, you can't do a trace back. So you got lots of these script kiddie tools that people download from IRCs, and they get mad at each other and they throw it at it, and they hit, right? Now, when you drop a packet, you send an ICMP unreachable back. That's backscatter. Now, if somebody advertised bogon space, what happens? Well, now you have a route, right? And all these script kiddies, they're constantly going, because we know we have all these script kiddies constantly doing attacks. All this low latency backscatter, all of a sudden, that's getting dropped in all these different routers, all of a sudden wakes up and goes, oh, let's go, go to this point. And you become a vacuum, sucking all this backscatter into you. Boom, you get hit, all right? So even filtering on bogons, you need to consider that, because with all this low-level script kiddie attacks going on in net all the time, using the bogon space, it can hurt you, right? So something to consider on that, right? Most of the time I get called in, like, you know, I'm kind of attached with our PSER, on Cisco, our security reaction team, and they'll call me up, or CERT will call me up and say, hey, this provider's under attack, or something's going on here. And most of the time they say, oh, BGP's under attack because they're hitting port 179. When you dig into it, most of those attacks are not BGP attacks, because it's very hard to spoof. They don't even, a lot of times they don't even get down to accept on the TCP stack. But they do hit, and they do hurt, because what happens is they're resource saturation attacks. They're packets that come in, they get queued up, because a lot of times they're present at 7. So they go into your SPD queues, you go into input hold queues, and they're there. You got to look at them, you got to drop them. So your route processor skyrockets through the roof. And if they get intense enough, you drop your routing protocols. So the routing protocol effect is a side effect of resource saturation. And this is something that I hope all of you who are vendors out there, all vendors should be out there really working hard trying to build resistance into their gear for these sort of attacks, because this is the big attack vector going after networking gear, is resource saturation. You know, and the pass in there is like, if you got a forwarding ASIC, you know, as you punt out of the forwarding ASIC, the CPU that supports the forwarding ASIC, if you plug into a backplane, the backplane can be saturated, the input buffers can be saturated. There's a lot of saturation points you can go after a piece of network gear. And believe me, because this is probably 50% of my job inside Cisco, is looking at all these points and trying to find resistance points. So everybody should be doing this now. This is a well-known threat, and my customers are all telling me that we've got to do this. Okay? Summer 2001, architecture. Architecture affects security. Summer 2001, we had Code Red and NIMDA. Okay? And Code Red and NIMDA was really interested because, you know, oh, it doesn't affect ISPs. It's like hitting a lot of end hosts. But actually, it hit a lot of ISPs. The reason why, there was a bunch of ISPs out there who are running default. Right? Now, default in an ISP is basically a Code Red and NIMDA magnet. You know, it says, because Code Red and NIMDA, the way the algorithm worked, it was just working all over the different address space in this little algorithm. Each one had its slightly different jumping algorithm. You know, and it would go out there looking for things, and a lot of times it was hitting Vogon space and hit other things. Well, you know, if you run in default, you suck everything. It says, I'm default, come to me. And you had, you know, a router sitting on a transoceanic gateway, and then, you know, send all Code Red traffic to me. You know, I'm going to drop it to null zero, but send it all to me, and the router, you know, goes down the tubes, right? So the architecture relates to this. So look at the architecture. Security bugs have been kind of scary out there, right? But luckily with the security bugs, we catch them in time. So, you know, by the time the hacker community says, oh, wow, this looks like an interesting exploit vector, the operators have already, the end vendors of operators have already patched it and got it all, you know, patched up on the network. What is scary, though, is that we're getting more and more of the intercompatibility issues. You know, those of you who are dual vendor, you know, operators out there, you're the test bed today. In the old days, maybe 5-10 years ago, there were actually events where we actually had competitor routers come together and they would interoperate. You know, not operationally off on a net, but unfortunately that is broken down. And that's one of the feedback we gave to the U.S. government that could need help with, right? So that to get, you know, 2 operators together, 3 operators, 4 operators, anybody who speaks BGP, to make sure they speak in BGP with each other properly and not have it tested on an operational network. Community attack. This we just threw out there because we haven't thought of really any community-based attacks. But as you saw in the presentation yesterday, you know, community, you know, inflation, where lots and lots of community, you know, prefixes of communities on it, you know, do happen. And, you know, there could be people poking around with, what can I do with adding lots and lots of communities? Adding lots and lots of communities, you already know, takes up a lot of memory, okay? So it already consumes memory, consumes memory on every router down the path, right? So that's something to think about. We don't have, I don't think there's a lot of people out there doing community ingress filtering. You know, a lot of people haven't thought about that, but I think after some of the stuff that was presented yesterday and thinking about it for security, people may want to go down that path and explore that avenue, whether it's worthwhile to do community-based filtering ingress into your network. Okay, so what's next? You know, these are kind of some of the things is what's next, all right? IPsec, I get this a lot. People say, oh, I want to put BGP over IPsec, but I go, what do you gain? right? There's a lot of people saying, what do you gain, right? It's kind of interesting idea, but what do you gain? You know, if it's very hard to spoof and hijack a BGP session, then what's the IPsec give you, right? You know, keep people from wiretapping, but if somebody's wiretapping, you got other problems. Maybe your resources should be spent somewhere else. So IPsec, but people are looking at that, right? So we'll see if that pans out, all right? SBGP, right? Now, SBGP has been controversial, right? And people are looking at that, but actually, you know, if anybody has read it before, go back and reread it. Because if anything, the work for all the SBGP work has put together some good articulation about the other problems with authenticating the source of the advertisement coming in the network. You know, there's a bunch of areas that we're kind of exposed with that we have, you know, we have some issues there that they've got it all documented well together. And there has been some changes with SBGP as they've been involved in doing testing with it. So if you have not read it before, go and read it. If you've read it in the past, like a year ago or so, go back and reread it. It will be passed into RPSec, right? So we'll be taking that work in there for people to start looking at that and considering with it. And this is the URL, if you don't know where the URL to get all the information for SBGP, all right? Towmine, people say, well, Towmine security. Well, Towmine's working on something else. But see, Towmine's working on filtering, right? So it's working on your ingress and egress filtering, working on keeping our table down. But as we do that sort of filtering, what that's going to result in, as the work from Towmine comes out and we start figuring out exactly here's what we're going to do and here's what we're going to deploy, that is actually going to add more security resistance because it's going to keep people from playing other games with, you know, better route filters out there, right? So if you're not on Towmine, this would be a good operators list to be on. Now RPSec, just starting up, just getting charted. I think the first working group meeting is going to be in Yokohama. And this is kind of like working through the assumption that says, okay, let's look at our, you know, route and protocol security. What, you know, even classifying, do we have a problem, right? So some of the first work is going to be, do we really have a problem? And what do we want to do with it? So this is kind of like one of the key what next that we'd like to get active participation from operators, right? It's not good to have an IETF working group where you have a bunch of vendors sitting there, right? That's dangerous. You want operators in these sort of meetings because it affects what is done and the results and everything. So we're looking to get more operators into the RPSec efforts, okay? And then a new one's popping up, right? And this email address, kind of email to me actually if you want information on this. In working with SANS and UNet and some other individuals from Digital Island Exodus and everything, we realized that routers themselves needed to have more robust security requirements so you can have it consistent. Because UNet was always getting frustrated because they see vendor A, vendor B, vendor C, and they're not consistent across the three on how they do ACLs or how they do logins, and they were getting extremely frustrated with that. So they started doing requirements, and then in consultation with them, you know, we were saying, why don't we do a supplement to RFC 1812? This is wrong. It's not 1918. It should be 1812, which is the router requirements document. All right. So the router requirements document for IP version 4 is out there, and a lot of router vendors use that to say, this is what my router should do. You know, if I get an ICMP and I drop a packet, you know, these are the things I should do. Like the packet comes in, I have no route, this is what I should do, right? So that work went on years ago. And we're looking at supplementing that with security requirements. What should you expect out of every single product that comes in your door from a security standpoint? So if you're interested in this, just email this alias because it will go to George Jones, or email me, and we're going to start up an alias around it. There's already a draft, so we got a draft. So we got something to work with. And we haven't decided whether to take it as an informational RFC or to take it as a working group. That would be like a consensus sort of thing of what people want to do with that. Okay, and acknowledgement, we got the white paper out there that you can download, look at what we submitted in, and acknowledgement with all these people that helped write this together. I volunteered to be the editor to put it all together and write the work. But it was a very collective sort of effort that we put into it. And then we have URLs and references so you can go back and look at stuff. And then as we come up with updates, you know, I'll push them out onto some of the sites, whether NANOG site or archives that I dump most of my white papers and stuff out there. Okay, so any questions?
In Sandy's risk assessment, or even other risk assessments, they have had, one problem is the host security, which you just last covered, I believe, of the router. You know, the fact that it costs so much to get SSH for some edge routers that they don't pay for it. They say, I don't want even secure shell because people charge me that much more, and how much is security willing to do? So there's the router security either by cost or by availability of software. And what I thought your answer was is it's good enough. Is that the summation of your answer, or that you're going to work on it as far as router requirements to make sure we have even the techniques out there?
It's definitely not good enough. I mean, if you get a copy of the draft, you will find that there are so many things that Cisco is not consistent with yet when it comes to router security stuff. And that's one of my key jobs in my company. But we're trying to do is get consistent across. But on the CPE side, I know back when I was an operator, and this is like back in '96, you know, on one of my aggregation routers, I turned on CDP, collected where all my routers were, find out all the Cisco ones, and set up a little script, and found out, you know, 30% of the routers connected to that one aggregation router is about, you know, 80 routers on it. You know, Cisco, you know, password Cisco, enable Cisco, and you're in the router, right? Now, SSH doesn't solve things like that
bad
sort of
security
stuff.
all the way through, but doing it in clear text could make it even more fun. I mean, that's, you know, straight telnet to the router could make life interesting.
Yeah.
So you're working through the router requirements saying do better security as a host, right? Another portion of Sandy's data you talked about, which is, okay, now I'm in this insecure place and I'm going to send bad prefixes into the net. And what I think I heard you say is suddenly all the providers have done significant amount of filtering so that an injected bad prefix can't swim through the net and do bad things. Is that what I understood from the rest of the slides?
No, many providers do it, so it's compartmentalized. But my experience is that the filtering on the customer edge is a weak area, one of the key weak areas. Just like with BGP 38, with packet filtering, source authentication on the edge of network, we have the same problem on the routing side with multi-home providers. So that, as a minimum, that comes into the first step ISP. And then there's a next stage where many of the ISPs that I've seen around the world are not doing the next stage, which do egress filtering going out to their peers.
Right.
So not checking what's going out. So you have garbage in, garbage going out.
So we have GIGO, garbage in, garbage out, and even though we have filters and lots of good things, we haven't really instantiated those filters in lots of places. That's the summation. No whitewashing, no anything. So we're still and yet you say it's good enough security. I wondered why you made that when we still have plenty of holes for the BGP structure to come in. And then I wanted to know where you thought the access list would improve that. I'm not downgrading it. I truly laud all your work and all Sandy's work and all the long-term work of everyone, but I'm just a little confused by how you can make the statement it's good enough when there's significant...
It's good enough from the context that we're not going to have the net fall over. One CPE router sending a bogus prefix in there, you're going to have providers out there with the way they set up their filters not going to allow that prefix into their network. Because they're going to,
So from your knowledge of the filters, you believe that the filters are substantial enough that there are firewalls at some places in the net. Right.
So you're not going to have an internet-wide, and we know this through experience from seeing these sort of incidents and incidents that I work at. We'll see like somebody inject a content provider's prefix in, a more specific, they send in a /30, okay, and it starts sucking in the traffic. But that /30 only goes to 2 other ISPs, right? And in some cases doesn't even go to the end provider. It's just so it's compartmentalized with.
So you're going to not have a network-wide failure, but you can see hijacking of individual prefixes based on how good the filters are around that particular prefix.
And because we know filtering works with that, and we know we can compartmentalize it, if you just go through and start looking at how your filtering policy is set up, you can mitigate a lot more of it. A lot more can be done just with the tools we already have available to
Sure,
us.
and that indeed is part of my questioning, that it didn't seem to leave out that we, should we use the tools we already have?
Yes.
We might get better.
Yes.
The next sequence of this is Sandy's work on actually securing, and SBGP's work securing this says, okay, some way I'm going to secure the originator of the data, that this data is time-stamped with my seal, like you said, a letter with a seal on it. I didn't notice any of that. You sort of said, in my understanding of the slides, and it may be faulty, you sort of didn't go down that path, and I wondered why you didn't go down that path while pointing toward the SBGP work.
I kind of relate those as similar in a sense, and I wanted to point people more to RPSec because I think we're going to probably view Sandy's work, view the SBGP work, and kind of really look at what's operationally feasible. Looking at both of those and going to customers and saying, is this stuff that we should do, like the coding stuff? They come back and say, well, how are we going to deploy it? So we got a lot of work to do on both sides, so how to figure out how are we really going to deploy it.
Okay. I mean, in IDR, we've had 2 or 3 presentations from SBGP, and the last I've checked with them, they haven't made substantial forward motion on that, in that there's still a lot of computational. Although it's a terrific idea, the computational requirements in that have been significant. And are you telling me that the SBGP stuff has taken a computational, I mean, they're essentially caching path IDs or security IDs. Have they gone forward with that?
That hasn't changed, but I don't think this audience, everybody is in those meetings in IETF. So one of the things I'm trying to do here is draw out more participation in those efforts, right?
Great. I just
yeah.
Thank you very much.
I didn't want to go down that path because I think that was more appropriate for the working group in IETF.
That's funny because IDR finds that this might be a more appropriate situation. So thank you.
Right.
With respect to the comments you made about SYN flooding for BGP, I actually tried on a Zebra box with TCP SYN cookies, 10 meg SYN flood, and it kept on chugging along, no problem. Are you implying, I guess, that if I was to try that on my Cisco 7206, that it wouldn't take it so well?
With a 10 meg SYN flood, you'll run in. It depends. It's hardware dependent. So the 7200, I know specific. Other platforms I know, I've throw 10 megs at it, and I run into other things, other bottlenecks inside.
I guess
so it's situational, right? Situational. If you take a 10 meg SYN flood, what's a link?
I guess to get more detail is in other words, is there no support for TCP SYN cookies in iOS?
Oh yeah. Well, we do some other things.
Okay.
We do some other things in the iOS stack that is similar to the cookies. So if you get a successful SYN acceptance coming in, with the TCP stack is saying this is a valid TCP session, you've done a successful spoof, right? Then we got some other things that take over that's related to the SYN flood protections that we could see on Unix boxes.
So I guess by your kind of fuzziness there, then I probably shouldn't try it on a live machine. I should try it in a lab first.
Try in a lab.
Okay.
Try in a lab. Okay.